In this lecture, we will discuss more problems and learn how to find the equivalent and non-equivalent protons. The next example is like CH3 CBr2 CH3. So we're going to find the number of types of protons. So just open the structure. So this is here 2,2-dibromopropane. Okay. Now see these three protons. If you compare these two protons, they are equivalent as they are connected to carbon. Carbon is further connected to carbon, which is connected to 2-bromine, and next is a methyl group. So all three protons, they are equivalent. These three protons, they are also equivalent. Now you will compare this proton and this proton, whether they are equivalent or non-equivalent. They are also equivalent. You can see the same environment. This hydrogen is attached to carbon, which is attached to carbon having 2-bromine and 1 methyl group. Same for this proton. It means you will get one peak. Like all the protons are equivalent. All these 6 protons, they are equivalent. Okay, next example is CH3 CHCl CH3. So in this case, these three protons and these three protons, they are equivalent, but the proton attached to central carbon, that is different. So it's clear that this compound gives 2 peaks. Okay, next example is CH3 CH2 CH2 Cl. Now see how many types of protons are there. As these three protons are different from these two, these 4 protons, they are not equivalent. As you can see, these protons are close to chlorine. They are far away from chlorine. They are again more far away from chlorine. It means all the protons are non-equivalent. So this molecule gives 3 peaks. Okay. Now there are some examples in which there are some exceptions. Exception means like different connectivity give non-equivalent protons, same connectivity give equivalent protons. But there are now some exceptions like same connectivity are non-equivalent protons. There may be some exceptions. You can see that the same connectivity get non-equivalent, same connectivity but non-equivalent. So this is exception. See the example, CH3 C double bond C, Br here, hydrogen here. Now you can see, it's clear that these two protons, they have the same connectivity. As this proton connected to carbon, further carbon double bond, methyl and bromine. This proton also connected to the same carbon, and again the environment is same. But these two protons, in spite of their same connectivity, they are non-equivalent. Why it is so? Because their environment is different. You can see here, like this bromine, this hydrogen is trans to methyl, but cis to bromine. This hydrogen is trans to bromine and cis to methyl. It's quite different. Environment is different. This proton is cis to bromine, but this proton is trans to bromine. This proton is trans to methyl group, but this proton is cis to methyl group. That's why they show that different peak. Like these 3 protons, they are equivalent. They will give only 1 peak. Okay. So this will give another peak. This will give another peak. So this is an example which show the exception behavior, like same connectivity generally are equivalent proton, but here the same connectivity atoms, they are non-equivalent. Such type of protons are called diastereotropic protons. So it will give 3 peaks. Diastereotropic protons. Okay, like one more example is we have hydrogen here, chlorine here, Cl, double bond C, H, H. Which two protons have the same connectivity? Like these two protons, they have the same connectivity, just like the previous example. But this proton you can see is a cis of chlorine, but this proton is a trans of chlorine. Its connectivity is different. So it will give 1, 2, 3. 3 peaks. Okay. As how will you distinguish B and C? This is cis to chlorine. This is trans to chlorine. That's why they are non-equivalent. Their connectivity is same, but there is an exception that some molecule connectivity may be same, but the protons are non-equivalent. Okay. Next example. Another alkene molecule. Now see this carefully. In this case you can see that the connectivity of these two hydrogen is same, as well as their environment is same. So both are equivalent. Now they become equivalent. As you can see here that this proton is cis to this methyl, trans to this methyl. If we see the environment, this proton is cis to this and trans to this. It means both have the same environment. If you see the connectivity, this proton is connected to carbon, which is connected to carbon-carbon double bond and 2-methyl. Same for this proton is connected to the same carbon and then carbon-carbon double bond and 2-methyl. Connectivity is same, as well as environment is also same. It means both these protons, they are equivalent. So right here B and these 6 protons, they are equivalent. It will give 2 peaks. Okay, next example is, say we have a benzene, methyl here, methyl here. This is paraxylene, 1,4-dimethyl benzene. How many types of protons are there? Hydrogen is here, hydrogen is here, hydrogen is here, hydrogen is here. Now see, these 6 protons has the same environment as these 3 and these 3 protons, they are equivalent, A. These 2 protons, this one and this one, they are equivalent. But if you compare these 2 protons, they are also equivalent, as you can see. As this proton is methyl this side, this proton has methyl this side, same. Or it means all these protons, they give a single peak. So overall this molecule give 2 peaks. Okay, next example, again benzene. If we have a such type of compound, Cl here, methyl here. How many types of protons are there? So you can see here is also a proton, here is also a proton, here is a proton, and here is a proton. Okay. Now clear that these three protons, they are equivalent. But these two protons, they are also equivalent. There is a methyl group adjacent to these two protons. But this proton and this proton, okay, if you compare this and this, they are non-equivalent. As you can see, the environment or connectivity of this proton is with chlorine adjacent to this is ortho to chlorine, this is meta to chlorine. They are different. Means these two are same. So C, C, it will give 3 peaks. Okay, next example is like amine. How many peaks this molecule will give? Okay, here we have a CH3. Here we have a CH2. Here we have a CH2. So all the protons are different. So this will give A, B, C, D. 4 peaks. Okay, one more example of some heterocyclic compound. See how many peaks this molecule will give. Now, here are 2 protons. Here are 2 protons. Here are 2 protons. And here are 2 protons. These 4 protons, these 2 and these 2, they have the same connectivity as downside CH2, CH2, upside the nitrogen. It means they give a single peak. These 2 protons and these 2 protons give a single peak, B, and this proton give another peak. So this molecule give 3 peaks.